Hi guys. In this video actually I plan to discuss about the difference between the secured multi-party computation and the smart contract programs. So as you all know, smart contracts, it's being deployed in an blockchain using Solidity or Rust or Lego contracts or even the Haskell contracts in different platforms. So in Solidity, in Ethereum, we use Solidity to deploy, and also in some cases Rust. And in many of the other blockchains like Cardano, we use Haskell contracts, and in Tezos, Lego contracts are being used. So in SMPC, there is no contracts, but there will be programs to execute. Now, in an SMPC, when I say SMPC, it's like the full form is secured multi-party computation. But this is the diagram that what you see. It's not a secured MPC. It's a multi-party computation. And in this, I'm just taking two parties. One is Alice and Bob. So here you can see that the function or the program is the shared program that has to be executed is x plus y, z is equal to x plus y. And each of the parties will know only one of the inputs, not all the inputs here. So in this case, the Alice, the first party, will know only the x value, and the Bob will know only the y value here. So if they have to execute it and if they have to verify it, they have to get the inputs from each other. So the Alice will get the input from Bob, which is a y, and the Bob will get it x, and then it will be executed. The program will execute and it will work in a proper way. But here the problem is that it is not secure because the values are being passed directly to the Bob, and it should not be the case. You need to be doing some sort of encryption here. So how you will do that, that will be taken care in the SMPC section, which is a secured multi-party computation. And in this case, you see that of course the Alice knows x and knows y. Now the thing is that how they pass the inputs, they are using the Peterson commitments, or they are using only the commitments to be passed. They don't pass the exact data to the particular party. So this has been passed in that way, and then they use the keys to decrypt it, and based on that the computation happens. So the encrypted data that's been passed, and then after that they learn the particular key, and based on the key, based on the private keys, they do the decryption of it. So there is a permission, and based on the permissions, the keys are being shared here, and then the Z thing has been computed. So in case of threshold encryption here, actually what happens is that you don't have to get the approval of all the parties. The keys will be distributed between all the parties, and only T out of N parties has to sign it, and based on that the computation happens. So that's one of the things where the computations are distributed, and it is the inputs are distributed here especially. And once the inputs are distributed based on the collaboration between the parties, the output gets executed. So the inputs should not be shared between the parties. That's how the secured multi-party computation is. And if it is shared, then it is a bigger problem. Because there could be dishonest parties, and they will be able to execute, and they will be able to give a different output. They may be able to modify the inputs, and that can cause the protocol to collapse. So in case of SMPC, it's a protocol here. It is not just a program where you need to have in this case, a two-way communication, and based on the two-way communication between the two parties, the program gets executed. But that's not the case with the smart contract programs, because let's say the same program where the Z equal to x plus y, and you have different computers, and here each computer will have the smart contract program, and it will execute all the inputs because it has all the inputs. So it is a deterministic state where the same program and the same input values are given to different computers or different parties who are part of this a block creation program, and then they need to get all of them, or most of them has to get that particular same output. And once they get the same output, they communicate with each other, and if it is fine, if it is right, then they create a block out of it. So the blocks will contain that, in this particular instance, the block creation has happened, and there is before getting in the blocks, they have to reach the finality state, and that's been done using the consensus program. You may have heard of proof of work, proof of stake, and delegated proof of stake, and different type of consensus, where all or honest number of parties, or majority parties, have to say that this particular program is giving the exact output. So this can be declared as finalized, and based on that, the blocks gets created here. So the block creation and the block finalization that happens based on the communication between the computers with the same inputs. So this is a basic difference, that in MPC you have inputs distributed between different parties. Here the inputs are, all the inputs are passed to all the parties here. So here the determinism and the verification is happening between the computers, and there the inputs are kept as secret. So there it should be a protocol in SMPC case. In the smart contract, it should be always a smart contract program. So the SMPC, which is the secured multi-party computation, the protocol is being developed in a different. Each of these are the different protocols to acquire the SMPC. One is that SMPC with honest majority. That means that all the parties that are participating in that, it assumes that this protocol works with the honest majority of participants. And the second one is of semi-honest. That means that out of 10 parties, it will be like the 5 parties will be honest and the other 5 parties will be dishonest. Means that there could be attackers, or there could be the hacker type of parties that will participate here. And with the honest majorities, out of 10 it could be like 6 or 7 because it's honest. And with the identifiable about, that means that if some parties are being identified as a dishonest, then this protocol will abort it. With a dishonest majority, that means that most of the parties will be dishonest, and based on that the SMPC protocol will work. And this is mostly it's been used by many of the banking mechanisms, because this is something like it takes a good amount of throughput, it takes a good amount of time to execute, but this is much more practical. And this is about the multi-party quantum computation, which means that we are not going to use normal computers. It will be like quantum computers with a publicly verifiable identifiable about. That means that in a trustless way, it will be verified that most of the users are dishonest, and it will abort it in a public way actually. So that's the last one. So last one is only with the quantum computers, but the other 4 protocols are based on the normal computers, means it includes the CPUs and GPUs. So this is the one that I want to share. Please click a like on this video if you like it, and if you have any questions, please let me know. Thank you.